Welcome everyone. This is the task video for the series on energy. We will do some practice questions on the different aspects that we covered in this series. Have your pen and paper ready to answer the questions. Pause the video after each question if you need to, so that you can work out the answer before going to the next question. Let's begin. A crane gradually lifts a car with a mass of 1,000 kilograms at constant speed to a height of 5 meters. Calculate the potential energy of the car at that height. A trolley and a sandbag have a combined mass of 4 kilograms. A bullet with a mass of 150 grams is fired toward the trolley and is launched in a sandbag. Immediately after the collision, the trolley and sandbag in the combination with the bullet move backwards at 5.3 meters per second. Calculate the kinetic energy of the trolley with the sandbag and the bullet directly after the collision. A toy car with a mass of 2 kilograms is at rest. A horizontal force is applied to the trolley and it starts to move in the direction of the applied force at 4 meters per second. Calculate the kinetic energy of the toy car after it has experienced this force. When a plane descends from its cruising height to land on a runway, 78,400,000 joules of gravitational potential energy is transferred. If the mass of the plane is 40,000 kilograms, what was the cruising altitude of the plane before its descent? Now we have a question on how to calculate the mechanical energy. A pot plant falls off the balcony of an apartment. The balcony is 20 meters above the ground and the pot plant has a mass of 2 kilograms. After falling a distance of 2 meters from the balcony, the pot plant has a velocity of 6.26 meters per second. Ignore the effect of air resistance. Calculate the gravitational potential energy of the pot plant before it begins to fall. Calculate the total mechanical energy of the pot plant after it has fallen 2 meters. Is this a closed system? Explain your answer. Calculate the speed with which the pot plant hits the ground. Now we will do some application questions on the conservation of mechanical energy. Tarzan, mass 80 kilograms, is on a quest to save Jane. He runs towards a rope with a velocity of 12 meters per second. He grabs onto the rope. To what height will Tarzan swing? A jet pilot flying at 600 meters per second is flying in clear space. The pilot decides to drop 4,000 meters in altitude to a new altitude 4,000 meters above the ground. What is the jet's new velocity if it descends to its new altitude? Air resistance can be ignored. A cyclist with a mass of 55 kilograms coasts on level ground at 32.25 meters per second. He freewheels 20.5 meters up an incline of 30 degrees to the horizontal and grabs an overhanging tree branch. What is the velocity of the cyclist when he grabs the branch? In the next question, we will look at a roller coaster question. A roller coaster car of mass 500 kilograms starts at a point 80 meters above the lowest point of the track. The car starts at 8 meters per second down the steep track. There is no friction. What is the total energy of the roller coaster cart at the top of the track? What is the total energy of the system at the base of the roller coaster track? What is the velocity of the car at a height of 30 meters from the base of the roller coaster track? What is the velocity of the cart at the base of the roller coaster track? Grade 10s, these are just a few examples of possible questions on the topic of energy. It is extremely important that you practice a lot more, since this topic is again visited in grade 12 and will also be included in your final grade 12 paper. For more information, visit our website www.mindset.co.za/learn. Keep well. Goodbye.